Welcome back. In the last video, we created model 0, which is going to be our baseline model for our computer vision problem of detecting different types of clothing in 28 by 28 grayscale images. And we also learned the concept of making sure we rehashed on the concept of making sure our input and output shapes line up with where they need to be. We also did a dummy forward pass with some dummy data. This is a great way to troubleshoot to see if your model shapes are correct, if they come out correctly, and if the inputs are lining up with where they need to be. And just to rehash on what our model is going to be, or what's inside our model, if we check model 0 state dict, what we see here is that our first layer has a weight tensor. It also has a bias, and our next layer has a weight tensor, and it also has a bias. So these are of course initialized with random values, but the whole premise of deep learning and machine learning is to pass data through our model and use our optimizer to update these random values to better represent the features in our data. And I keep saying features, but I just want to rehash on that before we move on to the next thing. Feature in data could be almost anything. So for example, the feature of this bag could be that it's got a rounded handle at the top. It has an edge over here, it has an edge over there. Now, we aren't going to tell our model what features to learn about the data. The whole premise of it is the whole magic behind machine learning is that it figures out what features to learn. And so that is what the weights and bias matrices or tensors will represent, is different features in our images. And there could be many because we have 60,000 images of 10 classes. So let's keep pushing forward. It's now time to set up a loss function and an optimizer. Speaking of optimizers, so 3.1, set up loss, optimizer, and evaluation metrics. Now, recall in notebook 2, I'm going to turn this into Markdown. We created, I don't need an emoji there. So this is, by the way, we're just moving through this workflow. We've got our data ready into tensors. We've built a baseline model. It's now time to pick a loss function and an optimizer. So if we go back to Google Chrome, let's write here, loss function. What's our loss function going to be? Since we're working with multi-class data, our loss function will be nn.cross-entropy loss. And our optimizer, we've got a few options here with the optimizer, but we've had practice in the past with SGD, which stands for stochastic gradient descent, and the atom optimizer. So our optimizer, let's just stick with SGD, which is kind of the entry-level optimizer, torch optim SGD for stochastic gradient descent. And finally, our evaluation metric, since we're working on a classification problem, let's use accuracy as our evaluation metric. So recall that accuracy is a classification evaluation metric. Now, where can we find this? Well, if we go into learnpytorch.io, this is the beauty of having online reference material. In here, neural network classification with PyTorch. In this notebook, section 02, we created, do we have different classification methods? Yes, we did. So we've got a whole bunch of different options here for classification evaluation metrics. We've got accuracy, precision, recall, F1 score, a confusion matrix. Now we have some code that we could use. If we wanted to use torch metrics for accuracy, we could. And torch metrics is a beautiful library that has a lot of evaluation. Oh, it doesn't exist. What happened to torch metrics? Maybe I need to fix that link. Torch metrics has a whole bunch of different PyTorch metrics. So very useful library. But we also coded a function in here, which is accuracy fn. So we could copy this straight into our notebook here. Or I've also, if we go to the PyTorch Deep Learning GitHub, I'll just bring it over here. I've also put it in helperfunctions.py. Now this is a script of common functions that we've used throughout the course, including if we find accuracy function here. Calculate accuracy. Now, how would we get this helper functions file, this Python file, into our notebook. One way is to just copy the code itself straight here, but let's import it as a Python script. So import request, then we're going to go from path lib import path. So we want to download, and this is actually what you're going to see very common practice in larger Python projects, especially deep learning and machine learning projects, is different functionality split up in different Python files. And that way you don't have to keep rewriting the same code over and over again. Like, you know how we've written a training and testing loop a fair few times? Well, if we've written it once and it works, we might want to save that to a .py file so we can import it later on. But let's now write some code to import this helper functions .py file into our notebook here. So download helper functions from learn PyTorch repo. So we're going to check if our helper functions .py, if this already exists, we don't want to download it. So we'll print helper functions .py already exists, skipping download, dot. And we're going to go else here. If it doesn't exist, so we're going to download it, downloading helper functions .py, and we're going to create a request here with the request library equals request.get. Now, here's where we have to pass in the URL of this file. It's not this URL here. When dealing with GitHub, to get the actual URL to the files, many files, you have to click the raw button. So I'll just go back and show you. Click raw here, and we're going to copy this raw URL. See how it's just text here? This is what we want to download into our Colab notebook. And we're going to write it in there. Request equals request.get. And we're going to go with open. And here's where we're going to save our helper functions.py. We're going to write binary as file. F is for file. We're going to go f.write request.content. So what this is saying is Python is going to create a file called helperfunctions.py and give it write binary permissions as f. F is for file, short for file. And then we're going to say f.write, hey, request, get that information from helperfunctions.py here and write your content to this file here. So let's give that a shot. Beautiful. So downloading helperfunctions.py. Let's have a look in here. Do we have helperfunctions.py? Yes, we do. Wonderful. So now we can import our accuracy function. Where is it? There we go. Import accuracy function. So this is very common practice when writing lots of Python code, is to put helper functions into .py scripts. So let's import the accuracy metric. Accuracy metric from helper functions. Of course, we could have used torch metrics as well. That's another perfectly valid option, but I just thought I'd show you what it's like to import your own helper function script. Of course, you can customize helperfunctions.py to have whatever you want in there. So see this, we've got from helper functions, import accuracy function. What's this saying? Could not be resolved. Is this going to work? It did. And we can go accuracy function. Do we get a docstring? Seems like Colab isn't picking things up, but that's all right. It looks like it still worked. We'll find out later on if it actually works when we train our model. So set up loss function and optimizer. So I'm going to set up the loss function equals nn.crossEntropy loss. And I'm going to set up the optimizer here as we discussed before as torch.optim.sgd for stochastic gradient descent. The parameters I want to optimize are the parameters from model 0, our baseline model, which we had a look at before, which are all these random numbers. We'd like our optimizer to tweak them in some way, shape, or form to better represent our data. And then I'm going to set the learning rate here. How much should they be tweaked each epoch? I'm going to set it to 0.1. Nice and high because our data set is quite simple. It's 28 by 28 images. There are 60,000 of them. But again, if this doesn't work, we can always adjust this and experiment. So let's run that. We've got a loss function. Is this going to give me a docstring? There we go. So calculates accuracy between truth and predictions. Now, where does this docstring come from? Well, let's have a look. Helper functions. That's what we wrote before. Good on us for writing good doc strings. Accuracy function. Well, we're going to test all these out in the next video when we write a training loop. So, actually, I think we might do one more function before we write a training loop. How about we create a function to time our experiments? Yeah, let's give that a go in the next video. I'll see you there.